in this video, we're going to be looking at geometric sequences. So we just finished arithmetic sequences, and with arithmetic sequences, we had a common difference that we had to add to each term to get the next term. With geometric sequences, we have a common ratio that we have to multiply the first term by to get the second term, or the second term by to get the third term. So we have a common ratio that we need to multiply by each term to get the next term. Okay, so also something with this is we're not dividing. So if you look at a sequence and you decide that you need to divide the first term by 2 to get to the second term, you need to think about, instead of dividing by 2, what could I multiply by? And I would be multiplying by 1/2. So you just need to think about that. Because we've done arithmetic and you guys get the idea, and this is very similar in the sense that you're going to be working with formulas and you have to just be able to identify your information and plug into the correct formula and solve, I'm going to introduce the first two formulas to you. So this is u sub n equals ar to the n minus 1. And in this case, u sub n is the value of the nth term. Okay, just like it was with arithmetic sequences, it's the value of the nth term. So if I want to get to the 8th term, what is that term? That would be u sub n. A is the first term. Again, that part's the same. R, though, is my common ratio. And to find R, we're going to take any term, so maybe the 4th term, and we're going to divide by its previous term. So the 4th term divided by the 3rd term. Or the 7th term divided by the 6th term. Okay, that's how we find R. N is still the number of terms. So the number of terms that I want to find the value of, or the number of terms that I want to get to. Okay, and so S sub n here, so let's add that. S sub n is the sum of n terms. So we have our formula that doesn't involve sum, so this is just to find the like the 7th term or the 21st term. And then we have our formula for the sum, okay? Here's an example of a geometric sequence, and I just want you to see this because what we need to do to find a geometric sequence to find the common ratio is to say R is going to be the 2nd term divided by the 1st term, and that equals 1/2. But in order to be a geometric sequence, that has to be true for every term and its previous term. So I could say R is going to be 2.5. divided by 5. So 2.5 divided by the term before it, which is 5, and that is also 1/2. And I could check the last one. 1.25 divided by 2.5 is also 1/2. And so that works, and that is how you find R. Any term divided by its previous. Okay, on this example, we want to write a rule for the nth term, and then we want to use that rule to find the 10th term. So our formula is u sub n equals ar to the n minus 1 for geometric sequences, which is what we're looking at right now. So let's identify what we have. What is A? A is my first term. That's 3. What is R? R is any term divided by its previous. So maybe 12 divided by 6, and that's 2. So we're just going to plug A and R into this formula here to find the rule for the nth term. So we leave u sub n as it is, and we say A is 3. Now, when I write this R next to A, I'm going to use parentheses. We can write it like this in this formula because these are different variables, but it is multiplication. If I just wrote a 2 next to this, it would look like 32. So you need to put it in parentheses. 3 times 2 to the n minus 1. This is our rule. And it has to stay like that. We can't simplify it. You cannot multiply this 3 by this 2 to simplify it because this 2 has an exponent that would need to be dealt with first, and we don't know what that value is. So it has to stay just like this. But now we can use this to find the 10th term. So 10 would be n. So we can say the 10th term, u sub 10, is going to be equal to 3 times 2 to the 10 minus 1. Okay, now we can simplify this. This is going to be 3 times 2 to the 9th. You could type this whole thing either here or here into your calculator if you're very careful and you use the parentheses where I've put them, or you can break it down, but remember we have to deal with the exponent before we can multiply. So we would have to say 2 to the 9th power times 3. and that's going to give you 1,536, and that's my 10th term. So u sub n is 1,536. Okay? All right, I want you to go ahead and try this problem and find your A, find your R, and then write a rule, and then find the 10th term and check your answer with me. Okay, so A is 40. R would be like negative 20 divided by 40, which is negative 1/2. And so when we write our rule, we have 40 parentheses negative 1/2 to the n minus 1. That's our rule. That's all there is to that, okay, for geometric. So now I need to find the 10th term. So that's going to be 40 times negative 1/2 to the 10 minus 1. And again, you can simplify this to 9 up here. But you need to make sure that if you're going to do this in stages and not type this whole thing into your calculator the way you see it, then you would need to do negative 1/2 to the 9th power and then multiply that by your 40. And when I do that, I'm going to get negative 5 over 64. That's my 10th term, so negative 5 over 64. Okay, on this example, we're given that the common ratio is negative 4, so R equals negative 4. And then we're told that the 5th term is 12, so we need to be very careful with that because the 5th term, 5th would tell me that n is 5, and that 5th term is equal to 12, so that would be u sub n. So our formula here is u sub n equals AR to the n minus 1. And in this case, we're asked to find the first term, so we don't know what the first term is. So we can take this formula and we can plug in what we know. We know that u sub n is 12. We know A is what we don't know, it's what we're looking for, so we're going to leave that as A. R is negative 4, and then n would be 5, so we would write 5 minus 1. And let's simplify this a little bit. This is going to be A times negative 4 to the 5 minus 1 is 4. So this math can be done in my calculator. Negative 4 to the 4th power is 256. And so if I have A times 256, I divide by 256 to get A by itself. So A equals 12 over 256, which you can simplify to 3 over 64. So that allowed us to find A. And then now if I wanted to, I could write a rule and find the 70th term or the 22nd term or something like that, okay? But we needed to find A first. All right, I want you to take a minute and I want you to try this problem. Okay, it's asking us to find the common ratio, but we're given the first term, and then we're told that the 7th term is 512. So go ahead and try to set up this equation, and then solve it, and check your answer with me. Okay, the first term is 8, so A equals 8. The 7th term is 512, so n would be 7, and u sub n would be 512. And then we're asked to find the common ratio and a rule for the nth term. So remember, this is our formula. Okay, so we can plug 512 into u sub n. We know that A is 8. We don't know R, that's what we're trying to find, but we know that n is 7 when u sub n is 512. So 7 minus 1. We can simplify that a little bit. 7 minus 1 is 6. So this should look familiar to you. You guys know how to solve this. We need to move the 8 first, so we're going to divide by 8. When I divide by 8, I get R to the 6th on this side. And 512 divided by 8 is 64. Now this is where you got to be careful because in order to get R by itself, we are going to take the 6th root of both sides. So R is equal to the 6th root of 64. But anytime we take an even root, we have to put plus or minus in front of our answer. So the 6th root of 64 is 2, but because that's an even root, it's plus or minus 2. So in this case, R could be positive 2, or R could be negative 2. And we don't have the sequence to look at the values, and we're not given enough information to decide whether R is the positive 2 or the negative 2 because we only have the first term and the 7th. So when we write our rule for the nth term in this case, we're going to say, well, if R is positive 2, then u sub n is going to be 8 times 2 to the n minus 1. That's our rule. But if R is negative 2, then we're going to have u sub n equals 8 times negative 2 to the n minus 1. Okay, so it's important to understand that in some cases R could be either, and sometimes they'll tell you. So if they said that all of the terms in the sequence was positive, well, it'd have to be this one, where R is positive 2. But here, this negative r is going to cause my sequence to alternate, positive, negative, positive, negative. So if we knew it was an alternating sequence, then it could be this one. But we weren't given enough information to decide, so we have to do both. Okay, so let's look at this example. The second term is 4. Again, remember they're telling us the term number, so n equals 2, and it is 4, so that's u sub n equals 4. So we're going to have 4 equals ar to the 2 minus 1. Since this is geometric, this is where I'm going to start. I can simplify this to ar to the first power, and you don't have to write the 1 if you don't want to, but this is as far as I can get with that piece of information. I have 2 variables missing. We're also told that the fourth term is 36, so when n is 4, u sub n is 36. So I can say 36 is equal to ar to the 4 minus 1, and we can simplify that to ar cubed. So what I have here is 2 equations with 2 variables missing on each equation. And guys, we did this with arithmetic, but this is a system of equations that we need to solve. Now I'm going to give you a really big hint for this that's going to make your life easier, so you may want to write it down. We need to get a variable by itself in one of these equations. It doesn't really matter which one, it can be done both ways, but I'm going to tell you that it's always going to be easier to get a by itself, and to do that in the equation where r has the smallest power. Again, I want to get a by itself, and this one has an r to the third, and this one has an r to the first, so I want to do it with the one that has r to the smallest exponent, and I want to get a by itself by dividing by that r. So I have 4 over r equals a. If you always do it that way, it makes your life a little bit simpler, because I'm now going to plug this into a. And so that looks like this. 36 equals, in place of a, we're going to put 4 over r, and then we have r cubed. Well, this r cubed is on the top, and this r to the first is on the bottom. So that's our exponent rules. 36 equals 4. When we have an r to a power on the top and the same base to a power on the bottom, we subtract powers. So this becomes r squared. And then it looks pretty simple, and you guys know how to solve this. So we're going to divide by 4, and we're going to get 9 equals r squared. And then to get r by itself, we take the square root of both sides. So we get r equals plus or minus 3. Because when we take the square root of both sides, we have to put plus or minus. Now, in this case, we didn't get enough information in this problem to decide, do we have a sequence where r is positive 3? Or do we have a sequence where r is negative 3? And many times you'll be told that the sequence is all positive numbers, or told that the sequence is alternating. But in this case, we don't have that information, so we're going to do both. We're going to say if r equals positive 3. If r equals positive 3, then a equals, and I'm going to plug it in here. So this is what I'm going to use to find a, 4 over my r, which is 3. So if r is positive 3, a is 4 over 3. And using that, I can write a rule, u sub n equals 4/3 times r to the n minus 1, and I can find the 10th term, which is the other thing that we're asked to do. So in this case, u sub 10 would be 4/3 times 3 to the 10 minus 1, and that simplifies to 4/3 times 3 to the 9th. And if you do that math, you get 26,244. Okay? All right, so what if r is negative 3? A would be 4 over negative 3, so a would be negative 4/3. And u sub n would be negative 4/3 times negative 3 to the n minus 1. And so I can find the 10th term by plugging in 10. Now, in this case, if you do all this in your calculator, you actually get the same answer. You get 26,244, but that doesn't always happen. Many times you're going to get a different sign, so you have to be careful to check both. If they don't give you information as far as whether your sequence is all positive numbers or whether it's alternating, okay? When this happens and we get 2 possible r's, so we need to have a way to know which r we should use, or we're going to do both, okay? But in this case, we got the same answer, so it was fine. Okay. I want you to take a minute and I want you to try this problem. It's very similar to the last one, so look at the steps we did and then do this one and check your answer with me. Okay. the 8th term of a geometric sequence is, so 162 equals a times r to the 8 minus 1, because this was u sub n and that was n. So let's simplify it a little bit. AR to the 7th. The 4th term is 2, so 2 equals AR to the 4 minus 1. And of course we simplify this and we get AR to the 3rd. Okay, again, what you're going to do is you're going to look at this r has a 7th power. This r has a 3rd power. So this is the r with the smallest exponent. So this is the equation we're going to be working with, and we're going to solve for a. So we're going to divide by that r cubed. So 2 over r cubed equals a. So we're going to plug this into that a. So 162 equals 2 over r cubed times r to the 7th. Okay, now 162 equals 2. This is r to the 7th divided by r to the 3rd, and we subtract powers, so we get r to the 4th. Divide by your 2. 162 divided by 2 is 81. And we have 81 equals r to the 4th. So we take the 4th root of both of those. And so we get r equals. Now, anytime we take an even power, we get plus or minus 3. Okay, so in this case, we have 2 possibilities again. And in this example, we're not told either way. So if r equals positive 3, a here would be 2 over 3 cubed, because we'd be plugging in this r. So that would give me 2 over 27. So u sub n equals 2 over 27 times 3 to the n minus 1. Again, we're finding the 10th term. So u sub 10 equals 2 over 27 times 3 to the 10 minus 1. Okay, and when you do that math, you get 1,458. Okay? All right, but what if r is negative 3? If r is negative 3, a, when I plug in a negative 3 here and cube it, I still get a negative, so this becomes 2 over negative 27. And so u sub n would be 2 over negative 27, or negative 2 over 27, which is fine, times negative 3 to the n minus 1. And so when we plug in 10, I get 10 minus 1 up here. Okay, and in this case, we're also going to get that u sub 10 equals 1,458. Okay, guys, the reason we're getting the same answer for both of these is because we've been asked for the 10th term. And so you see that when I plug that in and I get 10 minus 1 is 9, a negative to an odd power is negative times a negative is positive. Okay, and here I get a 3 to the 9th, which would be positive, times positive is positive. But if I had asked you for like the 11th term, 11 minus 1 would be 10, so this would become a positive. A negative to an even power would become positive times a negative, and this one would have been negative, whereas this one would have still been a positive answer if we were finding the 11th term. So don't assume that they're going to be the same. Okay, one of them is going to cause us to have an alternating sequence where I have a positive value and then a negative and then a positive and then a negative. And the other one is going to cause us to have an all positive sequence in this case. So you just need to be careful and you need to check. Okay, we're going to stop there, review what you need to, and we'll continue in class.